While ISVs acted as the link between Earth and Pandora, each of them carried a pair of single-stage-to-orbit spaceplanes, enabling transport between orbit and the Hell's Gate compound on the surface. These Valkyries transferred passengers and cargo down to the surface and brought up refined unobtainium and what few employees were lucky enough for a return trip back home. The Valkyrie used a fusion power plant for all of its propulsion systems. It acted as the power source for the wing-mounted turbojets and could switch modes to function directly as a rocket engine for reaching orbit and doing large maneuvers once up there. When acting as a power plant, it could keep the turbojets running for multiple hours in their VTOL lift configuration. This enabled the use of the shuttle as an aerial platform for exploration and survey roles, or even as an improvised bomber. The VTOL capability also meant it could land or take off anywhere that was suitably clear of obstacles. The magnetic containment fields of the fusion plant could also be used for active EMF dampening, enabling the Valkyrie to function normally in Pandora's flux vortex. Extra passive shielding was also placed around the cargo bay. In order to facilitate cargo transfers, the bay was set up much like that of traditional large cargo aircraft, with a ramp to the rear, rollers along the floor, netting to help hold cargo in place, and fold-out seats lining the sides. There were also amp suit lock bars mounted in the high ceiling, which allowed the shuttle to deploy manned suits directly to wherever they were needed. After arriving at Pandora, the ISV dispatched its shuttles to carry up to 62 metric tons at a time down to the surface. Most of the entry approach was done by simply gliding. Only when reaching roughly 3,000 meters altitude were the turbojets started up. As the shuttle passed over the unobtainium mine on final approach to Hell's Gate, Scorpion gunships entered escort formation with it, and the jet transitioned fully to VTOL mode for touchdown. For the return to orbit, Valkyries could carry only 35 metric tons back up to the ISV. The turbojets were used for vertical takeoff before slowly tilting rearwards for the transition to forward motion. At 130 knots, the wings generated all lift by themselves, and the turbojets were fully locked into the forward flight position where they took the Valkyrie up to Mach 3. Hypersonic inlets then opened up for the transition to scramjet mode, where the craft accelerated at 3G up to Mach 7. Once there, the dual-mode fusion plant switched to running the two huge orbital engines for the final burn to orbit. This whole process took only 10 minutes to reach orbit from liftoff, but up to 6 hours to complete rendezvous, maneuvering and hard dock with the awaiting ISV. After the ISV's cargo capacity was filled, it departed for Earth, leaving the Valkyries behind. They were then converted to automated gas harvesters to skim propellant for future ISVs from Polyphemus's atmosphere. Unlike the thoroughly well-designed ISVs, the Valkyries had a few more strange elements in their design. To start with, the wings were mounted on the top of the fuselage like a cargo plane, rather than on the bottom like real-life spaceplanes. Were they mounted high in order to leave space beneath them for the rotating engines? While on that subject, why did the engines need to rotate? It's a little strange that the entire engine pivoted in place rather than just the nozzle, but this did allow for a great amount of control in the direction of thrust, since they could rotate beyond the vertical to face slightly forward. Since the shuttles used vertical takeoff rather than a runway, they likely had a reduced upmass capacity than they were actually capable of. Even a short runway could have been used. This was probably unnecessary though, as taking unobtainium up in 6 flights instead of 10 doesn't matter if it still takes a year to mine and refine enough to fill the ISV or to refill its propellant and antimatter tanks. Finally, it's unclear exactly where the scramjets and their hypersonic inlets were located. What were the vertical slots just under the leading edge of the wing root used for? They don't appear to lead to any of the engines, so they couldn't be for the scramjets. Clearly, the Valkyrie was not as carefully designed as its parent ISV, with a number of compromises made in the design between the requirements of a VTOL transport aircraft, minimizing heating during atmospheric entry, and maximizing speed for the return to orbit. However, visually the design was perfect. It's instantly recognizable as being a high-tech space shuttle, largely due to the two-toned color scheme. Despite its shortcomings, the TAV-37 Valkyrie was still thoroughly suited to its role of transportation, exploration and logistics, both for the hostile skies of Pandora and beyond. If you enjoyed this video, please leave a like and consider subscribing for more. Thanks!